Hey everybody, this is Alex Merced from alexmercedcoder.com, and you're listening to another episode of the Web Development 101 podcast. And in this episode, what I want to do is talk about some useful words to know in the space. These are words like memoization, concurrency, and what do they mean? So first off, memoization. So you might have, if you do a lot of React, you probably notice there's like a hook called like get memo, or use memo, use callback, that if you read the description, they memoize things. What does that mean? Memoization is a technique to optimize your code in the sense that make your code faster. Now, should you always rush to memoize things? No, because it does. There are pros and cons. So let's explain what it is. So the beauty of functional programming is that if you follow functional programming techniques, your functions are pure. Okay, in the sense that the only data that's used within the function is data that's passed into the function through arguments. So if I have a function that takes in x and y and returns the sum of x and y, that's a pure function. Okay, everything is always internal. So I can pass it two numbers via x and y, so let's say 2 and 4. It'll add them together and it'll get 6. But as long as I always pass the same two arguments, 2 and 4, it'll always return 6. Okay, and that's a pure function. You know that as long as it takes in the same input, it should always have the same output. And this gives us a few benefits. One, functions aren't interdependent. Okay, since I know that I'm not necessarily, since I know all my functions are independent of each other. So for example, anything the function needs on the inside, it was passed in from the outside. You could delete, modify functions without necessarily modifying how other functions work. So theoretically, to make it like pure, you'd even want to, pass in functions from the outside. So this is like where sort of like callbacks come in. So anything that function needs, you want to pass in. Meaning you can just literally remove and add a function without necessarily really affecting much of the rest of your program, because each function is sort of self-contained. But the other benefit is that since you know it's pure, you know that as long as it gets the same arguments, it'll always have the same output. You can now cache the results. And this is what memoization is. So you can create some sort of mechanism that says, hey, if the arguments are the same, well, we don't need to calculate this again. So we'll just use the cached results. This is really useful. Like for an adding function, it's not super useful because it's such a quick calculation. But if you're talking about like a really long function that does a really complex calculation and transformation that is expensive in the sense that it takes a lot of time to process that thing, memoization can be a huge way of optimizing your code. Okay? Because essentially what you're doing when you memorize a function is you're wrapping that function in another function that first checks, hey, are these the same arguments you've received before? And then if it has, then it grabs the result from basically an object. In this case, well, if we're talking about JavaScript, an object, but at the end of the day, some sort of hash table. And if it hasn't gotten these two arguments before, then it'll actually do the function, get the results, cache the results, in case in the future you decide to use those arguments again. So basically, if you're repeating the same arguments a lot of times, you're not doing that entire process each time, which saves time. So that's what you're doing in React when you use memo and use callback. What you're doing is you're saying, hey, I'm either in use memo, I have this variable that I'm calculating that's kind of expensive to calculate, and really it's only going to change if these numbers change. So if these numbers don't change, don't recalculate it. Just use the same cached result. In use callback, it's a function definition. I'm defining this function, and really this function will only change its definition if these variables change, so only redefine the function if these variables change. Okay, so basically the idea is if the inputs change, then change the thing. Otherwise, don't change it, don't rebuild it. And that can be very big and optimal. So while data is immutable and functions are pure, which can sometimes seem a little unintuitive in functional programming, um, by making the effort to have immutable data, and that's another benefit. Like if you have like collections of data, arrays and objects, and you know that they're immutable, then it's easier to test whether the same argument was passed in twice. Because this is an issue you have in, like, let's say, pretty much all programming languages. If you pass an array, you can't test whether you passed in the same array twice, because when you say, hey, does this array equal another array, you're not comparing the individual items in the array, you're passing the reference. Because arrays, hash tables, objects, any kind of collection gets passed as reference. So in that case, if you're modifying the array, the reference may be the same, but the data may be different. So saying, hey, is this the same array I passed in last time, becomes a little bit more complicated, because you have to compare the individual values to see if is it the same array. And if you're passing the same values, again, it becomes a more expensive check. I mean, I can think of a couple strategies, like, turning the array to a text or the object to text and then comparing it. You can kind of make that work, but at the end of the day, it would be much easier to just compare references. Okay, you can just say, hey, because again, turning an object or an array to text is still a more expensive transaction than just comparing two references. So if you assume that if the data has changed, you're going to pass in an array, a new array with different data, then you can just check, hey, is this array the same as the other array? You can actually just do equals equals this array, because the references will be different because they are different arrays. So since data is immutable, you know that, hey, if these are the same reference, the data must be the same, because the data doesn't change. That's kind of one of the benefits of immutable data. So if you keep your data immutable and your functions pure, you can use techniques such as memoization to cache the results of your functions, which allows you to prevent your functions from having to run every single time and do the full process unless the actual data changes. So that's what memoization is. It's a functional programming technique, but it does require data to be immutable. It does require functions to be pure, which is why, like, React enforces these things, and kind of gives you a framework where you just kind of naturally do things this way. Cool. So now that we've talked about memoization, next I want to talk about concurrency. What's concurrency? Because you always hear about this, like, oh, concurrency this, concurrency that. Yay, concurrency, it's so important. But why? Now, we live in a world, or at least once upon a time, when the computer processing power got faster. So again, there's a difference between the space on the hard drive, the amount of data you can save persistently. That's what your hard drive does. There's a difference between the amount of data your computer can store in memory, which allows it to run more complicated processes. This is your RAM. And then there's your ability for your computer to actually, like, run the different things that it wants to do. That's its processing power. And for the longest time, the way your processing power increased is that they just made a better processor. So you would have a single core processor. One core means, like, think of it as like one brain, and that brain would just get faster. So it would be able to do more things, think of more things more quicker. So in that case, you didn't have to think about that with programming, because at the end of the day, if you have one core, your brain can only think of one thing at a time. So, programming was just sort of single-threaded, single-processed. But nowadays, the actual cores, the actual processor, doesn't really get faster. Okay, the reason processors are quicker. Oops, there's an alarm. The reason processors are quicker is not because the processor is faster, it's because there's multiple cores. So that means the reason why our computers can do more is not because their brains are getting faster anymore, but it's because they have multiple brains. And that kind of changes the way you need to write code. This is where, like, concurrency comes in. So the idea is, if most traditional programming languages have lasted a long time, they weren't built with necessarily concurrency in mind because it wasn't necessary. You didn't have multiple cores, so you just had to send all your directions to one brain, and the faster that brain was, the more faster it got through your set of directions. Okay, and but ideally now what you'd like to do is be able to somehow take advantage of multiple brains and say, hey, I have like 4 brains. How can I pass these directions across these 2, 3, 4, whatever number of cores? So that way, instead of just one core processing all my directions, I can speed things up by sharing the tasks. This is concurrency. Okay. The idea of trying to get a lot of different things done at the same time. So concurrency doesn't necessarily require multiple cores, but this is the reason where like concurrency like becomes an issue. And there's different approaches to dealing with that concurrency. Like JavaScript still only uses sort of one thread, always kind of uses essentially one core. Now the way it deals with concurrency, so you can do things like promises and all that other stuff, the way it deals with that is through sort of the big deal with Java, specifically Node. The big deal with Node is the event loop. I should look into whether Deno handles things any differently, but Node has an event loop. So basically what happens is all the code is queued up in a line. And then what happens is that if you do something like a promise, you're saying, okay, hey, this thing's not going to get done right away, so go to the back of the line. Okay, because hey, you're waiting for like an API call to come in, and we don't know how long that's going to take. So, instead of waiting for that data to come in, you've already sent out the request, get in the back of the line. Once I've done everything else at least once, then I'll come back and check to see, hey, did the data arrive? So whenever you have these events that normally would block your code, meaning, hey, I'd have to wait for this thing to finish, it basically it creates non-blocking events. It creates an event that just waits and gets back in line, and we revisit that event when it comes back up in line. And this allows you to kind of queue up lots of different things happening at the same time, even though you're working with a single threaded process. Okay, so meaning only really, at the end of the day, the processor is only processing one thing at a time, but the idea is that if something's taking a while, you're passing it to the back of the line while the external things finish. Particularly requests to other servers, other kinds of things. Cool. And then also on top of that, like Node allows you to create child processes through the child process standard library, which just means you could create other processes. So if you did have multiple cores, you could create a separate instance of a process. And that's another way you can take advantage of multiple cores, is you could just run the process multiple times. So imagine like you open up several terminals and you open up several copies of your server that just point to different cores. That works too, but then like anything that's defined in memory is defined twice in memory. So basically you have two identical processes, and both of them are defining, let's say, this data in memory. So let's say then what's going to happen is that both of them are necessarily defining this data in memory. Now you could then, so in this case, you could use something like a Redis, some sort of memory database. So that way they can both point to the same memory database and share that data to make that process more efficient, but you're still necessarily doing the same process twice. This is where like a lot of newer languages like Elixir, Go, Rust, whatnot, they were created to create more options when it comes to concurrency, to be able to take advantage of sort of multiple cores and other techniques to create like faster software. So this is why like concurrency matters. That doesn't mean like, okay, abandon JavaScript, but again, just understanding like JavaScript has one approach to concurrency, specifically Node. I have to check if Deno maybe does things differently or opens up new doors since it's created in Rust. But the idea is that this is the reason why like people who are looking for that additional speed will look to these other languages, because they can allow them to take advantage of a faster server, a server that has like multiple cores. You can now run a much faster process, especially for high traffic applications. So just kind of want to kind of explain why that matters and like what that term means. And because again, if you're listening to this, you're an aspiring web developer, and you need to know what these words mean because you have to be able to talk shop. And whether it's because it's an interview, a client, or just with your colleagues, you want to sound like you know, you love, you are passionate and excited about this industry, about this technology, and so I want to share that knowledge with you. So you have a great day. I'll talk to you all later. This is Alex Merced from alexmercedcoder.com. Make sure to head over to devnursery.com and sign up for the Slack and Discord communities, and subscribe to my channel on YouTube. Follow me on Twitter at Alex Merced Coder, and have a great day.